Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is minimum number of swaps to make the string balanced. So you will be given a zero indexed string, okay, of even length. The string will be consisting of n by 2 opening braces and n by 2 closing brackets. Okay, so the number of opening and closing brackets in the given string will be equal. Okay, and the string is balanced if and only if the following conditions holds true. If the string is empty, then it is said to be balanced, or it can be written as AB, where A and B both are the balanced strings. Okay, so it can be written as a concatenation of two balanced strings, is also a balanced string. Okay, it can be either written as uh, opening and closing brackets, and then inside that C can be a balanced string. So these are three types of forms which are considered to be also the balanced strings. Okay, so you may swap the brackets at any two indices any number of times as you wish. Okay, and basically you have to tell what will be the minimum number of swaps that will be needed in order to make the given string balanced. Okay, so this is what we have to do. Now before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of the string will be of order 10 raised to power 6, and the length is of the string will be even, and there will be two kind of characters in the string. Either it will be a opening bracket or it will be a closing bracket. Okay, and the number of opening brackets and the number of closing brackets will be equal to the half of the length of the string. Okay, so these are the constraints. So now let's try to think of an approach how we can solve this particular problem. See, to solve this particular problem in the most optimal way possible, we will be using a two pointer kind of approach. Okay, two pointer kind of approach, as the name suggests, we will be using two pointers. Basically those two pointers will be pointing to the extreme ends of the string. Okay, so if we want to mark the indices of the string, let this be your given input. Okay, and now let's see how we can apply this two pointer technique here. So what we will be doing here is we will be doing swaps only when the close bracket count is greater than 0. Okay, so what we are doing here is, see, we are taking opening brackets to be decrementing a variable close count. Okay, it represents how many close brackets have you seen till now. Okay, initially close count will be set to 0. Okay, so basically you are saying that all the brackets are balanced as of now. Okay, if you are seeing a closing bracket, then you will be saying that okay, the number of closing brackets that we have seen till now is increased by 1. Okay, and then if you see a opening bracket, then you will say that uh, the number of closing brackets is decreased by 1. So in a way, when the close count is 0, it represents the state when the brackets are balanced. Okay, but what you will be doing here is, as soon as the value of close count exceeds greater than 0, it means that you are seeing the close count for the very first time. Okay, see, if let's consider a case of a balanced bracket. So balanced string. Okay, so this is the balanced string. First of all, you see the opening bracket, then you decremented the close count value which was initially set to 0, now it's -1. Okay, next time you see a closing bracket, then you increase the value of this close count, and it went from 0 -1 to 0, and 0 represents the state when it's balanced. Okay, and if it is the other way around, let's say if it is an unbalanced string, then you would be seeing the closing bracket before the opening one. Okay, so in that case your close count will be the number of brackets will be greater than 0. Okay, because it will be incremented by 1. So as soon as that happens, you will do the swap. So now we must be having one opening brace, so that we can do a successful swap and it will lead to a balanced pair. Okay, so in order to have that opening bracket, we would be selecting that opening bracket from the end. Okay, so we will be choosing it from the end, because you see it reduces the chances of the misbalances that might be induced because of your swap. Okay, so there are less chances of that this opening bracket might be paired with some other closing bracket. Okay, so we will be selecting it from the opposite end. Okay, and so this is the situation in which the two pointer approach will come in handy. So we will be using a pointer, let's call this left. Okay, and another pointer, let's call this right. So this left will be doing what it will be moving in this direction, and right will be moving in this particular direction. Okay, so they both will be moving close to each other. Okay, so what will be happening is, so right will always point to the opening bracket. Okay, from the end. Okay, so it was the first opening bracket, so right was pointing to it, and as left found a closing bracket, then it incremented the close count, and your close count went from 0 to 1. Okay, now you should be doing the swap. So if we swap these two values, so it will be looking something like this. Okay, so now we can say that if we disregard what is in between these two, then at least this portion is balanced. Okay, so now balancing changed the value of the close count. How it changed? See, the first thing it did was that your close bracket is now no longer at this position. Okay, so your close bracket was contributing a positive 1 to the close count, so that would be gone. So you will be minus subtracting 1. Okay, and the second thing which happened is, now instead of that closing bracket, you placed a opening bracket, and that also decrements the close count by 1. So in all, we can say it will be close count in net will be decremented by 2. Okay, so now your close count will be, earlier it was 1, now it will be -1. Okay, because 1 minus 2 will be -1. Okay, so next time when you will be at this particular, your left will be at this particular closing brace, it will be increasing your close count to from -1 to 0, and 0 indicates the balanced situation. So you will be not doing any swap here, and you will be moving your left pointer from here to here. Okay, and as when you did the swap, your right have to be made to point to the next opening brace. Okay, and this whole thing will continue till, so this is the next opening brace, so right will be pointing here, and this whole thing will continue till your left and right pointers are, left is basically before right. Okay, so left is less than right. Okay, and then when these two either crosses each other or will be at the same, you know, uh, when they cross each other, basically you will be stopping this whole process. Okay, so now see, here at this particular point your close count will be 1. Okay, so you will be needing to do a swap again. So this time these brackets moved and the swap happened. Okay, and again after doing a swap, so after doing a swap, the value of close count went from 1 to -1. Okay, and again you encountered a opening bracket, and while you will be moving to this place, then you see from -1 it went to -2. Then these two right and left pointers will cross each other and we will be stopping our process, saying that the whole string is processed and everything is balanced as of now. Okay, and you will be counting the number of swaps that you did. Okay, so this is the whole logic. Again I will be explaining. The whole logic was to decide will be the optimal situation when you will be doing the swap operation. So we took a variable close count, and close count will be presenting the number of closing brackets we have seen. Okay, it increases by when you encounter a closing bracket, and it decreases when you encounter a opening bracket. Okay, so the increase and decrease is to make sure that when the close count is 0, the value of it is 0, it represents a balanced string. Okay, so as when your close count is greater than 0, then you need a swap because your bracket, that particular bracket is causing imbalance. Okay, so we need to find a pair for it, and the pair should be a opening bracket, and we are choosing the opening bracket from the end so that it minimizes the number of misbalances that might be introduced because of the swap that you will be doing to you know balance out the current closing bracket. Okay, so then your left and right pointers will be moving towards the center, and when they will cross each other you will stop the whole process. Okay, and there was this logic that when we did a swap, we decremented the value of close count by 2. Okay, and this was the reason that the close bracket, first of all the close bracket will be gone, which was having +1, and instead of that we are on top of that we are introducing a opening bracket which is having a -1 effect. So in net -2 effect will be there when you do a swap operation. Okay, so this is the whole logic, and let's see the implementation part. If some things are not clear till now, then it will be clear in the implementation part. So let's take the code to the board and discuss how we have implemented this approach. Although most of the logic and the implementation I have told here here itself, but still let's take the implementation part to the board. So this is the implementation. So as we discussed, we will be returning a variable swap count from this function that we have to complete, and then will be having a variable close count representing the number of closing brackets that you have seen till now, and the value of the zero value of the close count represents that the string is balanced. Okay, then you will be doing a linear traversal of the whole input string. Okay, and before doing that, your right pointer, so you will be having basically two pointers pointing to the two extremes of the string, basically to the first index and the last index. Okay, so this will be your right and this will be your left. Okay, So when they are pointing to each other, you will be making sure that this right pointer is always pointing to a opening brace. Okay, so that when you need to do a swap, then you can easily see what is the current position of the right, and then you can do a swap. Okay, so this is to make sure that right is pointing to the opening brace. Okay, and this whole process of the linear traversal or processing of the string will continue till your left is less than right. Okay, so this is the condition. And when you see a closing brace, then you will increment your or brace or bracket, then you will increment your close count. Otherwise, if it is the other way around and it is a opening bracket, then in that case you will be decrementing your close count. Okay, so that next time you see a uh, you know closing brace, it neutralizes the effect of the last opening brace that you have seen. Okay, so whenever the close count happens to be greater than 0, it means that there is a misbalance. Okay, because of that particular closing brace, so we need to find a opening phrase brace for to be paired with that closing brace, and that will be, you know the balancing will be done by a swap operation. So for swap, because of swap operation will be happening, your close count will be decreased by 2, and the reason is uh, that we have already discussed. Okay, the because of this reason, that closing bracket will be gone, and it will be replaced by a opening bracket. Okay, so next, now your right will be no longer pointing to the current opening bracket, because it is already swapped with the closing one. Okay, so you will decrement your right and it will be moving towards the center. So both left and right will be moving in this fashion. Okay, and you will increment your swap count, obviously, because you just did a swap operation. Okay, and then you will be making sure that your right is pointing to the next opening brace from the end. Okay, and then you will be incrementing your left, or left will always be moving uh, one step at a time towards the end of the string. Okay, so and right will only move when you do a swap operation, otherwise right will be always pointing to the opening brace. Okay, and then once you are done with all this and left and right crosses each other, uh, then you will simply return the swap count. Okay, so this is the whole logic and the approach. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And before ending the video, let's have a quick discussion on the time and space complexities. So see, time complexity wise, we are doing a linear traversal here. Each character in the string is at most processed by only one time. Okay, so in that particular case, the time complexity will be, if let's say the length of this string is n, then it will be order of n, linear. Okay, and space complexity wise, see, other than using a couple of variables, we are not using any extra space here. So space complexity wise, this will be order of 1. Okay, or you can say constant. So if there are any doubts left in the complexity analysis also, then you can ask them in the comment section. I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.